Now we're going to do some exercises on exponential equations with involving rational fractions. Now let's start with question 1. Over here we have like x raised to the power of a half equal to 5. Now this is what we can do to get the value of x. Because the power is a half like this, we can just put another power raised to the power of 2. Actually, we're gonna do the inverse of this fraction 1 over 2. I'm gonna put the power of 2 over 1. Okay, and I do the same also on the right, 2 over 1. Now, over there we can just simplify like that. And then this will be okay, don't worry about that, just okay. This will be we simplify this 2 with that 2, and then this will be x equal to 5 squared, which is 25. Okay, the same way we did, let me go over it. So it's like x to the power of a half equal 5. So what we do, we raise this part, both sides of the equal sign, by the power of 2. I wrote 2 over 1. Okay, and then we simplify. In order to simplify that fraction, okay, we put the power of 2 because 2 and 2 will cancel, and then we can have x and 2. So we can do the same over here in question 2 and in question 3. But question 3 can be much quicker because anything raised to the power of over here, for instance, we know that x is just going to be 1, okay? But you can apply the same technique here, here, and there, okay? And all over, even 4, you do the same thing, okay? Over here, you raise to the power of to the power of 3, and then over there, you can say to the power of 4, and over here to the power of 5, okay? Over there, okay, let's do question 5. Question 5 will be x to the power of 2 over 3 equals to 4. So we do a similar thing over here. Then we will put this to the power of the inverse is going to be 3 over 2, and then also instead of me writing 4, I prefer to write like 2 squared. Okay, so I'm going to raise it to the power of 3 over 2 also. Okay, whatever we do on the left, we do on the right. Why 3 over 2? Because 3 over 2 is the inverse of 2 over 3. Over here, then we can simplify 3 and 3, and then 2 and 2. Then we will get x. And then there, over here, we have like the denominator is 1. You know, we can simplify also this 2 with that 2. And then it's going to be 2 to the power 3 over 1, which is just 2 to the power 3. That makes x is equal to 8. Okay. Same thing, the same way we did question 5, you can do question 6 and 7, even 8. Now let's do question 9. Question 9, we have like 3x to the power 5 equal to 729. Okay. So first thing to do here is to get rid of the coefficients 3. So to get rid of this 3, we will divide both sides by 3. We divide by 3. We divide by 3. And then that makes x to the power of 5 equal to 729 divided by 3 is equal to 343. And then to get now the value of x, it's if, for instance, in this case, I will do this, x to the power 5 equal to 343. In terms of its prime factor is 3 to the power of 5. Okay, now I will raise this to the power. Okay, I don't even need to do that. Over here I can just apply this method that says if we have like a to the m equal to b to the m, when the exponents are common like this, when the exponents are common like over here, what we do, it means that the bases are equal also. So over here, it simply means that x equal to 3. Okay? Or someone else may, over here in this case, like we can just cancel the exponent here, we say x is equal to 3. Or someone else may say, if it was x to the power of 5, and then equal to 3 to the power of 5, we can do this to the power of 1 over 5, and then there also to the power of 1 over 5. Why? Because this will be equal to, this will be simplified because this invisible one there, invisible one there, we can simplify 5 and 5, and 5 and 5, and then we get x is equal to 3. It's quite longer, but I will prefer to do this method applying this law of exponents. Okay, thank you. Well, now we're going to do question B, okay, on exponential equations with rational fractions. Now, let's see B1. Let's write the equation here. 1. We have x to the power of a half. Okay. Here it's x to the power of a half minus 7 to the power of 7x to the power of a quarter plus 12 equal to 0. I prefer to write it differently. Okay, instead of me writing a half, I prefer to write, I'll look here, this exponent is a quarter is more smaller than a half. Then instead of me writing a half there, I am going to write 2 over 4. You know that 2 over 4 is a half. I wanted to have like a same denominator as this one, okay? For good reason. You see that now, minus 7x to the power of a quarter plus 12 equal to 0. Okay, you know that x to the power of 2 over 4 is like x, it's like 2 over 4 is like 2 multiplied and 2 times a quarter. It's like writing x to the power of a quarter raised to the power of 2. Okay, this is same as that one. Okay, minus 7x to the power of a quarter, okay, plus 12. Now that I have a quarter over here and a quarter over there, we can do something like I will introduce something called the n method. Now let x to the power of a quarter is equal to n. Okay, but if there is a quarter, we substitute by n, so this will become like n squared minus 7n plus 12 equal to 0. 12 equal to 0. Now we have like a usual trinomial. Okay, I can just put n there and then n there, close bracket equal to 0. We're going to look at the last term as we usually do. The last term, which is 12. It's positive 12. And then the factors of 12 in ascending order are like 1 and 12, 2 and 6, 3 and 4. Now, if we do need to get a sum among the factors of 12 that is equal to -7, we'll see this is it can only be -3 and -4, okay? Because note that -3 times -4 makes positive 12. -3 minus -4 makes -7. So over here we can just place in -3 and -4. If you struggle to do factorization, I have a playlist on factorization, dedicated on factorization. We did so many factorization there. You can go there and then do trinomial, like in this case, how to factorize trinomial, etc. Then this will be n minus 3 equals 0 or n minus 4 equals 0. Because the law, one of the law in math says this, if you have like a times b equals 0, this implies a equal to 0 or b equals 0. Okay, so in this case n equal to n minus 3 equal to 0 or n minus 4 equal to 0. That means n equal to 3 or n will be equal to 4. Okay, then this means, remember, we were not to calculate n, we were looking for x. So n is x to the power of a quarter, so it's like x to the power of a quarter, if I substitute, equal to 3, or x to the power of a quarter equal to 4. Now to get the value of a quarter or of x is if I raise this part, okay, I'm gonna write here x to the power of a quarter equal to 3. I must raise this part to the power of 4. And then they also to the power of 4. Why to the power of 4? Because the power of 4 we cancel this 4 there. This one and that one we cancel, and then I'll have x is equal to 3 to the power of 4 is 81. Same thing I'll do on the other side. There it's like x to the quarter equal 4. So I raise this part to the power of 4, and then also to the power of 4. And then we know that this and that we cancel. And then we're left with x equal to 4 to the power of 4 is 256. Okay, so those are the values of x. X is 81 or x equal to 256. Okay, let me recap what I said. First of all, I look at the question as it was, x to the power of a half minus 7 to the x to the power of a quarter plus 12. Now, I wanted to write them, the exponents here, with the same denominator. Because this is a half, I can write that no, a half will be 2 over 4 if I want to make it the same denominator. Okay, I'll write it like this. Now, x to the power of 2 over 4 can be written as x to the power of a quarter to the power of 2. This is 2 over 4. Okay, because we times the product here, it's going to be 2 over 4. Now, once I got it like this, I have x to the power of a quarter here in the bracket and x to the power of a quarter there. We can let a quarter to be just equal to n. Now we substitute, it becomes like n squared minus 7n plus 12. This is a trinomial that we have here, equal to 0. Now we factorize this equal to 0. Remember this law, okay? If we have a product equal to 0, if a times b equal to 0, it means a equal to 0 or b equal to 0. So this means either n minus 3 is 0 or n minus 4 is 0. Now we work out the value of n. We got n is 3 and n is also equal to 4. But we were not meant to calculate n. We're looking for x. The question says solve for x. We write the value, the initial value of n was x to the power of a quarter, and then n also x to the power of a quarter. Now to get the value of x, we raise this part to the power of 4, and then also to the power of 4, as we can see in the following line. Okay, because we can simplify 4 and 4, and then we got x is 81, and then we do the same there to get the answer. So the same way we did question 1, you can do question 2 and 3. Okay, I will leave this question even 4. So 2, 3, and 4 is for you. Okay, I could also leave, yes, even 5. I leave that for you to practice. Maybe let me just do, but it is the same thing. Okay, the same way. Try it out. Maybe I'll do which one? Okay, let me do. I do ini mini mo in French. Le bon Dieu a dit que ça sera pour toi. So I'm gonna do question 4. Okay. Question 4. It was x to the power of 1 over 3. Okay. Minus 6x to the power of 1 over 6 plus 8 equal to 0. Now, first of all, I want to get this denominator common. Okay, so in the fractions. Okay, so I can write it as x, instead of writing 1 over 3, I'll write it 2 over 6. We do know that 2 over 6 is 1 over 3. Okay, minus 6 to the power of 1 over 6 plus 8 equal to 0. Okay, now 2 over 6 here can be written as 1 over 6 to the power of 2 minus 6x 1 over 6 plus 8 equal to 0. Now we're going to let n to be equal to 1 over 6. So now let's say let n equal to x to the 1 over 6. Now the equation will become a trinomial. Form of trinomial is going to be like n squared minus 6n plus 8 equal to 0. Over here then we can factorize. Okay. I will write 8 over here, and factors of 8 are 1 and 8, 2 and 4. Okay, if I need to make a sum equal to -6, this is possible only if it's -2 and -4. So I put -2 and -4 there. Then, okay, you know what to do here. We apply that law we said, if you have like A times B equals 0, this implies A is 0 or B is 0. Okay, so in this case, excuse me, n minus 2 is 0 or n minus 4 is also 0. This means that n equal to 2 or n equal to 4. Then we will substitute the value of n, which is x to the power of 6, 1 over 6, I mean, equal to 2, or n equal to, x to the power of 1 over 6 equal to 2 squared. Now, if we raise both sides to the power of 6, to the power of 6, and then to the power of 6, to the power of 6, and to the power of 6, this will become x equal to 2 to the power of 6 is 64, or x there, it's going to be 2 to the power of 12, which is 4096. Okay. So the same way we did this, what else can we do? Yeah, the same way we can also do with question 6 here. Over there, you know, it's 1. The power, the invisible power here is 1. So instead of say x to the power of 1, we can say x to the power of 2 over 2. Okay, to have that's the same denominator as here, and then apply the same technique. Thank you. If you do like the video, please, and it's your first time, subscribe to the channel, and thank you. Don't forget to hit the notification button